Good afternoon, everyone, and welcome to Professional Developers Conference 2008. My name is Frank Savage, and as the Monty Pythoners used to say, and now for something completely different. I'm going to talk a little bit about game development with XNA Game Studio 3.0 and how that works, and give you kind of a rough intro of what you can do, both from a demonstration perspective and also from a coding perspective. I'll actually walk you through building a game here. Quick and dirty. Hopefully I won't mess up too badly. I've had about 3 days to practice this and probably way less sleep than I should, so bear with me. It could be fun. I've been in the game industry for 17 years now. I started at Origin Systems down in Austin, Texas. Did a game called Strike Commander and another game called Wing Commander 3 down there. This is actually the Wing Commander 3 ship shirt, which still fits me. So it's hard to stay in shape after 17 years in the game industry. You can see what it's done to my hair. After Origin Systems, went to Foss Interactive Technologies up in Chicago. Did Mech Commander and Kibitz on the Mech Warrior games there. Foss Interactive Technologies was acquired by Microsoft in January of '99. So I found myself at Microsoft there, finishing Mech Commander 2 and the expansion to the first Mech Commander game. Then I went over to the Xbox Advanced Technology Division, worked there on the first Xbox for developer support, basically helping game developers get the most that they possibly could out of the Xbox platform for the first console. Was part of the team that helped bring up the second console, and was part of the team actually from day one that built XNA Game Studio. So I've been on this for about 4 years now, from the first demos where we got the compact framework running on Xbox 360 development alpha kits, which were actually Mac G5s. All the way through to today. So I know quite a bit about it, as you may imagine. So what are we going to talk about? Well, first we'll talk a little bit about what is XNA Game Studio and what you can do with it. Actually show you creating a game live here in front of everybody on camera, so that'll probably go real well. Talk about the creator community and the new methodologies we'll have for being able to publish these games actually into the Xbox Live community games section as well. So we'll start with what is XNA Game Studio. For those of you who have ever been to the website, you'll recognize this is kind of the branding and logos we have for a lot of this. The website is creators.xna.com. And we had a couple goals when we built this. The first was to enable aspiring game developers. And this was more the hobbyist, the enthusiast, the student, the people who've always wanted to make a game but never have had the time to sit down and fully wrap their heads around the DirectX SDK. They didn't have access to the Xbox development kits anyway, because you have to have a Microsoft Publisher's licensing agreement to do that. So give these guys the opportunity to make games on our platforms was a big deal that didn't require months and months of research and bringing things up, but in fact could be done very, very quickly. Which leads to the second point, which is to make this significantly easier. Game Studio sits on top of Visual Studio 2008, the 3.0 version does. And all of the game development is done in C#. So if you know C# and you appreciate the rapid application development gains that C# and the .NET Framework get you, this is going to feel right at home. Provide educational solutions using the Xbox 360 as well. We're in over 1,000 universities now are teaching game development using C#, using the .NET Framework, using the Xbox 360. Obviously a pretty big win for Microsoft there, but it's also a pretty big win for the students. Today it's very difficult to attract kids to computer science degrees, and having a kind of gaming curriculum does that. The kids want to come and make computer games. That's what I wanted to do. So what games do we have that we can show off here? So I actually have an Xbox 360 here. It's running the new dashboard that's going to be coming out here within the next month. So for those of you who haven't seen this, you can also play with this. We have an XNA booth kiosk in the big room. You can come by and check out some of the stuff that's there. Some of these are games that were built by the community. So we've had 2 Dream Build Play contests. Both contests ran about 6 to 8 months. And the prize for the first contest was you got Xbox Live Arcade contracts to actually take your game to Live Arcade. So there are 3 games going through the process of certification right now for that: The Dishwasher, Yoho Kablamo, and Blazing Birds. With the second Dream Build Play contest, we actually just gave people money because they can actually publish these games into Xbox Live community games starting here tomorrow, actually, when we release Game Studio 3.0. So these are some examples what the games look like. one of the questions, a lot of the question that gets asked is, well, it's C#, and there's a garbage collector, and it's managed, and how fast could it really be running? And this will give you some kind of idea of what you can actually do. This is a game that was written in China. It was done by, I believe, 4 students. There's a really great intro to this in that they didn't spend a lot of time translating this into English very effectively. But it does have that Kung Fu Hong Kong movie feel to it because the translation is like that. "I'm not your biological dad" is a great line. That's okay. "No, I am not. I must tell you the truth now. 20 years ago, you were brought here by my brother, who was a guard in the Forbidden Palace, and he asked me to bring you up and teach you Kung Fu." So you can just imagine how this would, immediately resonate with anyone who's seen one of those movies. So rather than show you all the excitement that's there, we'll actually jump into it here. And this is sort of a standard kind of fighting game here, but this is all 3D, running on the Xbox 360. The Xbox 360 is using the .NET Compact framework, not actually the desktop framework from Windows. So this is the same framework that's on mobile devices as well. The CLR and everything is exactly the same. So you can see that perf isn't too bad. It doesn't look too bad. And you can actually, I will spend about 3 hours playing this here. Hit these guys 34 times in a row. You can see I play this a fair amount. And the idea behind this is, you just keep fighting until you lose. And so you can fight for a fairly long period of time before you lose. If you're me, if you're not me, it takes you a significantly shorter period of time. It does get way hard very fast, which is exciting. So another piece that we did was a game called, this is another Dreamville Play game called Battle Tennis. So this is a kind of a standard tennis game, but of course, most people who work on games or who are aspiring game developers also get very excited about the idea of having things blow up. Blowing things up is kind of a staple of game development, really. And what would a tennis game be without balls that exploded or could be powered up in some way or that could injure the other player in some way? So this was their attempt at showing some of that. You can see the load times are pretty long for some of this stuff. We actually fixed a lot of this in Game Studio 3.0. All of the content that you send over to the Xbox 360 today, the textures, the shaders, all of the meshes, all of those, the sounds and things like that are actually compressed now before they're sent over. And they stay compressed on the Xbox 360 hard drive, which is great because loading them in compressed is much, much faster than just loading them. The Xbox 360, well, it does, you can get anywhere up to 120 gig hard drive for it. They are the slowest 120 gig hard drives on the face of the planet. So you get to watch the thing count up here. This is the ticking part of it now. They do actually do a pretty good job, and then it doesn't get to 100% and sit there. At least it hasn't traditionally. It probably will today because I said that. Instead, it exits a little bit early, and then you can actually jump in and do stuff, which is kind of fun. So, yay. So there's actually a story mode. The story mode is interesting in that you can actually follow one of these players all the way through a long story arc. And you can see that we have very somewhat stylized characters as well here. So we can pick a bunch of different kinds of characters. I can be Fei-Fei the panda, for example. I can be a robot, which is also kind of fun. So let's see. There we go. So now it starts loading again. This is the problem with demoing this kind of stuff is there's lots of lovely load times. This one is actually running faster though. But what's cool about this is, again, these were all hobbyists, enthusiasts, student people. These were not professional game developers that built this. And you can see that we actually have something that looks, from a 3D perspective and from the playfield perspective with all the little things flying around and everything else, not too bad. And so I can actually play this here, and then eventually you build up enough power so that you can really blast it at them. There you can see she you actually left sparks there on the ground, and there I'm taunting her because I beat her there. My little paddle being racked up means that I've actually got some extra power in that now, so there's a, I can't remember what button it is. Or we could just exit unexpectedly. So there you go. So clearly I pushed the wrong button. Perhaps I pushed exit by mistake. Another thing that's interesting about the Xbox 360 is that we actually give you access to all 3 cores. The Xbox 360 has 3 PowerPC chips inside of it with 2 hyperthreads on each chip. And so this was a demonstration we did. It's probably barely visible. But it's basically a particle system that has 150,000 particles in it with 2 attractors. The 2 attractors are pulling the particles together. They're colored based upon which attractor is currently influencing that particle most strongly. Green being the one attractor, red being the other attractor, and then yellow where the attractors are about even because red plus green is yellow in computer graphics. But there are 150,000 particles running here, and all of this is actually running on the CPUs on the Xbox 360, not the graphics processing unit. And we did this on purpose to show off that there is actually quite a bit of power on the Xbox 360 CPUs, and that you can actually multi-thread them. So we're splitting this job, 50,000 particles on each core, and you can see we actually get a pretty decent frame rate here of 27 frames per second. When I first wrote this, it came out at about 6 frames per second on the Xbox 360. And so my first inclination was to go find the people responsible on my team for the XNA framework and hurt them in some way. But instead, I actually went and found out that there's a whole bunch of ways that you can make this optimal. And I do an hour-long talk on this as well to talk about optimization and how you can make things run faster using a .NET framework. So my interest in gaming goes all the way back to the Wing Commander era. I was actually a pretty big Wing Commander fan back in the day. I actually had license plates for my car before I started working at Origin that said Wing Commander to give you some kind of idea of the level of geek that you're seeing here. And I'm sad because there really aren't a lot of good space games today. So I thought, well, maybe I should write one then. And this is a space game that I'm currently working on. Again, it's going to be a little hard to see here until I get something bright on the screen. So the Xbox 360 is actually loading all of the high-resolution textures here for the Earth in the background. You can see it res up there. And you can see that you can actually get a fair amount of detail here on the Xbox 360. So this is 60 frames per second in C#. The Earth is composed of about 9 different texture layers here, all being combined using Shader Model 2.0. There's night side lights here as well. So you can see on the night side we've got that going on. We've got the atmospheric halo, specular reflection on the oceans. The clouds are all casting shadows as well, as you can see there. And the clouds are all bump mapped as well as the terrain being bump mapped. So you can actually do quite a bit of pretty impressive graphics here. And this is actually running at 60 frames per second on the Xbox 360, not 30 or anything like that. So we can make some pretty cool stuff with this. Not only is it rendering the Earth, but the rest of the planets in the solar system out to Saturn, several dozen of the major moons. The star field that's behind here is actually a real one. You can see Orion right above the spaceship there. And then off the Hyades, and then the Pleiades over there. If we go all the way up to the north, we should be able to see the Big Dipper, which I sometimes lose because it's so fun to just look around. But anyway, all the stars are there, and these are actually being processed from the Hipparcos Tycho database. There's 150,000 of the closest stars that we actually have parallax and color information for, as well as proper motion for, thanks to the ESA's Hipparcos satellite. All that's being loaded up and actually rendered here in real time, as well as the Earth. So 150,000 stars, the Earth with 9 layers at 60 frames per second. Give you some kind of idea of the power that the Xbox 360 really has. All in C# with managed code on the .NET Compact framework. So fair amount of power in what we built here. So let me set the Xbox 360 back to listening mode here. So the way that you develop for this is kind of interesting in that you run the XNA Game Studio Connect application, and we charge basically $100 a year subscription to run that application. The application download's free, but it doesn't help you much unless you have the subscription, because when it connects, it won't see a subscription, and then it gets mad. So how did we build this? Well, we had 3 platforms, 2 platforms actually originally that we were originally interested in, which was Windows and Xbox 360. We recently added Zune. There was a community tech preview for Zune development in May. The real release of that is coming out, like I said, tomorrow. So you can actually make games for the Zune as well. The Zune is a little bit different from the Xbox 360 and Windows in that it doesn't have a 3D part inside of it. But it does have a fairly good 2D part inside of it. So you can do alpha blending and some of the other things with sprites really effectively with it. And it is a strict subset of the APIs that are available on Windows and Xbox 360. So you can actually develop on Windows and then just connect your Zune up and have it go. And it'll go ahead and run the game pretty effectively as long as you don't use any of the 3D calls. I'll give you an idea of how you do that. The XNA framework consists of two high-level pieces, the application model and the content pipeline. The application model is basically to abstract away all the things that the game developer doesn't have to worry about. And that's things like creating the device on Windows or the Xbox 360 or even the Zune. It's things like pumping Windows messages through the application so that everything works correctly. We take care of that for you. It's things like being able to load content very effectively, textures, shaders, those kinds of things, very easily with single commands. Being able to draw with very simple commands. Being able to run audio with very simple commands. The content pipeline is the piece that actually builds all that content for you. So if you make games, or if you ever tried to do this, you realize that getting 3D content into your game is actually pretty hard. First, you've got to go build it in something like a Max or a Maya or a Lightwave or an XSI, and then you've got to import it or export it from that package into some format that hopefully your game can understand. Then the game has to import it. The data's often not the way that you thought. The windings are wrong. The UVs are wrong. Something's crazy about it. You've got to write converters to fix all that. The content pipeline actually standardizes a way to do all of that, and we actually provide you importers and processors for .x formats, the .filmbox format from Autodesk, for WAV files, MP3s, WMAs, very nearly every kinds of 2D graphics format you can imagine. All of those are already automatically provided for you, and they just automatically build the content in a way that Game Studio can understand. We also built the low-level pieces of the framework as well, and these are basically the namespaces. So nothing surprising here: graphics, audio, math, input, networking. Networking is interesting because this is actual connection to Xbox Live kind of stuff. You can actually build games that are multiplayer that connect to Xbox Live, where friends can be on live with you and play. Basically, the only two things that are missing from the 3.0 version of Game Studio are achievements, because the very first game would be give me millions of achievements and a very large gamer score, so we decided that was bad. And then the second one is leaderboards. Right now we don't support the back-end leaderboard stuff that's in live today, but we're going to try to get both of those actually with an upcoming version here if we can. But everything else for networking is there. You can have rich presence. You can have the ability to see what your friends are playing if they're playing these games and so forth, and all of that will be supported with live community games that are coming up. And there's also a gamer services piece. This lets you access their profile. So everyone who logs into the Xbox 360 has a gamer profile. That gamer profile not only tells me their name, what kinds of games they like to play, but it also tells me things like, do I like to have Y inverted on my joystick? Because a lot of people like Y inverted from when they learned how to play Halo originally, like me. Unlike my son, who does not like it inverted and hands me his controller and says, "Oh, are you having a hard time, Dad?" And then blows me up. So on top of all this, we have XNA Game Studio. And Game Studio is running today in Visual Studio 2008. It runs in all of the Visual Studio 2008s from Express, C#, all the way through to the highest end SKUs. The content pipeline extensions are also in Visual Studio 2008, and they're all run using MS Build. So you can actually type MS Build and your content project name, and it will just build from the command line if you wanted to. You're under no obligation to do it inside Visual Studio. And we also have the device manager there, which essentially says, this is the Xbox 360 and the Zune that I want you to connect to and send the game to when we start debugging or playing. Games are different beasts from traditional applications for a couple of reasons. One is they tend to be real time. Games have a frame rate, and the frame rate is ideally 30 or 60 frames per second. And people perceive changes in that frame rate very differently than you might imagine. A relatively slow frame rate that's very even is perceived as good, whereas a very fast frame rate that has big hitches in it is invariably perceived as bad. So we wrote a lot of the application model in the framework to make sure that we didn't get hitches, that we ran as fast as was humanly possible. But being a real-time application essentially means that we load stuff up, we start up, we load all of our content, we call update, and then we call draw, and then we keep rinsing and repeating until such time as you tell me that you're done playing the game, or the game decides that it's had enough and kicks you out, much like Battle Tennis did to me. When you're done, there's typically an unload content phase. This is to get rid of the stuff that the game put into place. Although we are managed code and it does do a fairly good job of cleaning up after itself, the framework actually has to throw away a lot of the Direct3D resources and DirectX resources that get created because those don't have really managed equivalents, and so that memory isn't really under control of the CLR. So we give all that memory back to the system when we're done, and then we end. And end is actually can be fairly complex as well. We got to get the Windows desktop back to the resolution you originally started in, perhaps the same color depth that you started in. We got to turn off all the sounds. We got to stop the controller from vibrating. There's a lot of stuff that you can forget to do when your game exits that we make sure happen so that you don't have to worry about it. So what does creating a game look like? First, I wanted to show you one of the starter kits that we have and give you kind of a rough idea of what Visual Studio looks like in this environment. So this is the platformer starter kit. If you've been to the show floor, you've seen this. You can see the little icon in the Xbox demo. Basically, your classic 2D platformer game. Guy runs around, jumps up on things, collects little gems, runs to the end, next level. This is a starter kit so that you can see how to do those kinds of things. We give you all the source. We give you all of the content. Classic Visual Studio starter kit kind of thing. We also give you all 3 platforms as well. And if you want to compile this for a different platform, all you have to do is set the platform you're after here to build and the platform you want to start, and you hit run. And you can see we're actually building, and what we're building here is actually content. So we're actually taking these PNG files and we're converting them to the graphics formats that the Game Studio pieces and XNA framework can understand. And then magically it starts running. And you can see that we have Indiana Jones-ish kind of guy here. Of course, we would never steal anyone's IP. And he can, it's very difficult to do with the keyboard, by the way. And then he can run over to the exit here, and you can just not get a lot of points. So you win. Congratulations. The idea behind this is not to ship a complete game, because if we just shipped the complete game with all the source code, you wouldn't bother programming it. You'd actually spend all of your time playing it. So we purposely left it so that there was work for you to do, so that you would want to do that work and then play the results of your labors. So let's look at what a new project looks like here. If we go to new project, you can see that we actually have a bunch of different new kinds of projects for Game Studio. There are Windows games and game libraries, Xbox 360 games and games libraries, Zune games and games libraries. We can also create content pipeline extensions. This allows you to create new importers or new processors. We do whole talks on that. And of course, the platformer starter kit, which would let you build a whole new platformer if you wanted to. So we're going to do a game called PDC Planet Defender. So when we say we want a new game, we get a whole bunch of stuff by default already built for us. We get a game CS file. And this game CS file has a game, which we inherit from Microsoft XNA Framework game. We create the graphics device for you. We create a sprite batch for you. A sprite batch is simply a way of drawing 2D art to the screen. We figured there's always some 2D art you want to draw to the screen, even if it's just, press Y to exit or something like that. Classic constructor, where we build the device manager, the root directory. For the content manager, basically says all the content for this game is going to live under content and a whole bunch of directories underneath that. There's an initialize function. There's also something called load content. Load content is there because we need to load the content in a specific way through a specific function so that if Windows changes resolution, if Windows loses the graphics device because the screensaver kicked in, because somebody locked their desktop, this will automatically reload all the graphics up to the graphics card when that situation comes back and you get the device back. This is actually an extremely difficult thing that professional game developers have to deal with every day. This is why a lot of games in Windows, when you Alt-Tab away from and you Alt-Tab back, you don't get the best experience in the world. This actually fixes that, so you get that good experience every single time. We have an unload content that lets you get rid of it on the fly in the game. Typically, nobody ever puts anything in there. They load everything for their game. They play. They go home. There's an update. In update, we give you basically pull the joystick or the Xbox 360 controller here, and if you see somebody push the back button, we're done. Otherwise, you need to put your own stuff in there. Again, you'll notice that there are base updates and base calls in here. This is where the pumps for the actual underlying framework go and actually run and handle all the stuff in the background that you don't need to worry about. And then when we draw, we simply clear the screen to lovely color.cornflowerblue and, again, call the base draw. And this is what happens. We sit there calling update and draw over and over and over again until such time as somebody pushes the back button or hits Alt F4 or any of the classic, closes the window in Windows. All that will work as well. We catch all of those for you. So let's actually get something going here. Well, let's look at what this looks like. So when you first run an XNA game, this is what you get. And I'm sure all of you are now sold because of that cornflower blue, if nothing else. So there's a long story about why we picked cornflower blue that I won't do here, but it's long. The under content, let's go look for some existing items here. So let's see, I put these in, please God, here. Oops, nope, this one. So here's a bunch of content that we can use to actually build this game. This saves me the trouble of having to run Max or Maya and having you watch me attempt to make 3D art in Max or Maya. because that's really not going to be enjoyable. We go ahead and we add this planet model, and if we check out the properties for this, we actually see that the asset name for this is just going to be the name from the file. We're going to tell it to compile. There's actually other actions we can do as well. We can just copy this raw data over to the resulting directory. The content importer is going to be the Autodesk FBX format, because we know that one. We're going to process it using the model processor from the XNA framework. And you'll notice that there's a whole bunch of parameters as well in here. This lets you set things like, for example, a lot of artists get confused about which way is up and in and sideways in 3-space. So ours is right-handed, Y is up. Sometimes they're like, oh, right-handed, Y is up. Got it. And then the model comes in. So what the X and Y and Z axis rotation is like, okay, rotate it 90 or minus 90 on Y, and that fixes the problem. That way you don't have to go back and constantly ask the artist to redo things, because probably this artist lives on another continent and is displaying or giving you this stuff out of the kindness of their heart. Or you found it in something like a 3D warehouse on Google or something like that, where you just imported it and are now using it in your game. So we have the planet model. That's all we need to do to tell it to deal with the planet model. Now we go into load content. And to load content, actually, now let's go up and create the planet model first. How about that? So in our case, we have a model that we'll call the planet model. And we'll go ahead and load the planet model here. And you'll notice that our loader actually takes a type, which is great, because we can actually specify what thing we think we're loading here. And that doesn't sound like a big deal until you start to get into things like cube maps and 3D texture maps and all these other weird types. And now you can actually make sure that, oh, the thing that I thought was named that is in fact this type, and that's actually really good and keeps you from crashing later on. Now we have a planet loaded. It would be probably good if we could draw it. So the drawing part of this, while I could recreate this from scratch, I will instead use the magic copy-paste methodology for this. And this is actually really simple. When we draw the model, we're going to hand it the model that we want it to draw, and we're also going to hand it a matrix. So for those of you who are all familiar with 3D graphics, you always need to transform this model from its local space into world space. Then you need to project that model onto the screen using a whole bunch of 3D calculations that involve typically 3 matrices concatenated together. The matrix that we're going to pass in here is what's called the world matrix. So these models all start right there, typically centered on 0, 0, 0 in your right-handed coordinate frame, right? What the matrix does is say, well, actually, you're out over there. And so translate yourself out over there. And then the camera provides that view and projection matrix that are listed here. And the view and the projection essentially say, here's where I am. I'm a camera. I'm looking this way. And this way is up, because I need all 3, or I can't really define which way my orientation is in 3D. And then it feeds the projection information as well. And the projection information is, what is my field of view? What is my near plane? In other words, anything drawing on this side of it, we're not going to draw. Anything on this side of it that way, we're not going to draw. That's the far plane. And then from the field of view and the aspect ratio, because these screens are not perfectly square, we actually get enough data to be able to define how all this stuff draws. And believe me, it's not something you sit down in an afternoon and kind of wrap your head around. So 3D stuff is not, we've made it as easy as we can, but it's still not 100% easy. But what we do is we're going to create a look at. We're going to move the camera essentially 32 world units along the z-axis here. We're going to have it look right at the center at 0, 0, and up is up. We already defined up for you in our reference frame. That's cool, so you don't have to remember, oh, is that 0, 0, 1? Is that 0, 1, 0? And then our perspective field of view here is going to be 1 radian wide. The aspect ratio is 1.33. Technically, that should be data-driven. And the near plane's at 1. The far plane's at 1024. So how do we draw the model? Well, we come in here and we say, draw a model. And the model that we're after is the planet model. And now we need a matrix. Fortunately, we also give you a bunch of helpers to create these matrices, so you don't have to remember how to build these by plugging numbers into a giant 4x4 array. And the first thing we're going to do is get the planet rotating, because if it just sits there, that's kind of boring. So we're going to rotate it by taking the game time that's elapsed, and this will be the total game time that's elapsed, and there is a difference between that and elapsed time. The The total game time is the amount of time that has elapsed since the game started running. So this is going to let it rotate on one axis. And the other thing we're going to do is say, you know, a planet that's rotating with its pole straight up in the air is kind of boring. So we'll actually rotate it just a little bit so that the planet is tilted sideways and rotating around that, is what that essentially does. So if we run, see we're building the planet model now, which actually is taking a fair amount of time. These can be very complex models. They can be hundreds of thousands of faces in some cases. And those FBX files are actually text files, so it's got a lot of parsing and stuff to do. And there we have our world rotating. So you can imagine that at this point that bad things are going to happen to this planet. And it will be your job to keep them from happening. So how do we do that? Well, now the next thing we need is, okay, we've displayed the model. It's in the center of the screen, but we haven't tied it to the joystick at all or the controller at all. So the next thing we need to be able to do is tell it how to do that. So if we add an existing item here to the project, and let's see, go back to here, and demo, and this. Let's see, I have a fully built one here just in case. Games typically implement something called a camera, and the camera takes that view and that projection matrix and kind of normalizes it into things that make sense from somebody who knows anything at all about photography or how cameras and lenses work, and kind of normalizes it. So field of views, being able to understand aspect ratios, the lens characteristics, all of those are programmed into this. And we've created a camera here that's from drawable game component. So we also have a set of components that you can build that if you inherit from drawable or just game component. And what those do is when you add those to your game component list, they simply get updated, drawn, loaded, initialized. All of the things that you saw in that typical game can happen in these components as well. And it's automatic. You don't have to worry about calling the loads or calling the initializes or calling the draws or the updates. It's automatically done for you. The cool part about that is that means that I can actually build code that's very, very, very easy to share in the community now. So I can create an orbit camera that inherits from camera. And the orbit camera has a bunch of information in it that basically says when I go to update, I'm going to go grab information from the gamepad. I'm going to translate that into the ways I want the camera to move and how it changes its field of view and whether it zooms in or out. All of those kinds of things can be programmed here. Cool part about this is, and I'll show you in a second, if you make changes to this camera or if you go and you download a new kind of camera and it follows more or less this paradigm of the right properties of view and a projection property and things like that, and it's a game component, you can just slot in the game component and it'll work. So let's actually see how we do that. Come up here. And we'll create an orbit camera that we'll call, oddly enough, orbit camera. Come in here and we'll create it. The orbit, any game component takes the game itself as a reference to it. That lets it save off the main class that holds the graphics device and all the other information that it needs to potentially draw itself or get information about the joystick or any of those things that are present. And then you simply tell the components list to add that orbit camera. That's it. Camera's now added to the list. It's going to get updated. It's going to get loaded. It's going to get rendered. All that stuff's just going to happen. There's one other thing we need to change, and that is that the camera itself is going to provide us with these views and projection matrices now. So we do that by simply pulling the view out. And I love this keyboard. Because end isn't really end, it's delete. And we need the projection matrix here. So that's it. Theoretically, at this point, we've now hooked in a new camera, and it should be tied to this thing. And it is. So I can zoom way out, zoom way in. Note how the camera keeps you from getting too close so you don't go into the earth. You can also rotate up and down. You can see that we actually have lighting. There was that enable default lighting that's there. We add a couple of small, simple lights to the scene for you. You'll notice I haven't done any shader programming. And that isn't because you can't access the shaders. You actually can. The difference is that we actually provide a shader that knows how to do pretty advanced stuff called the basic effect. And that way, if you don't really want to jump into shader programming to prototype your game, you don't really have to. When you want to go and make it really complex and you want this planet to have 9 layers like the Earth did that I drew, you can actually build shaders and load all the content and actually do that work as well. And it all works just fine. So we now have the camera. We now have the planet. Now we need to add in the pane. So those will be rocks, because it's always fun to throw rocks at things. To do that, we're going to need to bring in the rock model, which will be right here. We'll need to load that, which will be right here. Oops. Again, this is another model. The name that I'm typing in here, actually, you can set in those properties as well. If you didn't like the one that we gave you, you could actually make up your own ones if you wanted to. So that's going to get the model loaded. But we're actually going to probably have more than one rock here. And so what we're going to do is create a class to hold the rocks. And the class is going to need to store a couple things to tell us what we need to know about the rocks in order to be able to draw them. First is position. And again, that's in a vector 3 because I need an x, y, and a z to uniquely specify a position in 3 space. There is a velocity. The velocity is interesting because it also has 3 values, and it's not just the speed, in other words, how fast it's moving, it's also the direction in which it's moving. This is why those are vector velocities in game development versus just I'm going 60 miles an hour. What you're really saying is I'm going 60 miles an hour that way. And then we also need to know perhaps the most important thing, which is the rock dead? And we'll see why it'll die in a moment. So now we need my favorite part of the presentation here, which is to create the, yes, you guessed it, the rock collection. And make sure I'm putting everything in here I need to. So we also need a rock timer. What does the rock timer do? Well, this is going to tell us how often we need to create a new rock. Because just blowing up one rock coming in on the planet, yeah, that's going to be fun about one time. Then we also need a random numbers generator. This is at the very heart of game development. You don't want the same thing to happen every time because that gets boring too. Next thing we need to do is we'll clean up the state a little bit here because we may want to actually keep the gamepad state around. And what we're going to do is copy this piece off here. And that'll allow us to more quickly poll what's going on with the game pads. Let's see. You notice again that we have the player index 1 there. Now we just put the state here. And that lets us just pull the joystick or the controller once and do all the stuff that we need to be able to do. Next thing we need to be able to do is figure out, well, how much time has elapsed since the last frame was drawn and executed. We can actually get that from our game time as well, except this one is elapsed game time. And that's in total seconds as well. So that tells me how much time has elapsed since the last time I was in this update loop. And that is actually at the resolution of like the performance counter, so it's very, very high resolution. The next thing we need is to spawn rocks. And again, I will save you the trouble of watching me try to get this right and fill it with interesting comments while I remember what to type. So basically what's going to happen is really simple. When the rock timer elapses, which is what's going to happen here, we're going to check, we're going to subtract off how much time has elapsed. When that goes less than 0, we're going to create a new rock. We're going to create a new direction to spawn that rock in, which is going to range from -1 to 1 on the x, y, and z axes. We'll normalize that vector because we want a vector whose magnitude is 1 because that's purely direction. Then we're going to shove that out 256 world units. Then we're going to create a velocity that's the opposite of the direction that we shoved it out, i.e. right at the planet. And we're going to set the maximum of that velocity will be 8 plus 8, which will be 16, and the minimum will be 8, is what that does. We'll make sure the rock isn't dead. We'll add it to our rock list, and then we'll reset the timer so that 2 seconds later another one of these rocks will spawn. You'll notice that there's a lot of little hard-coded values in here. This is actually not typical of what game developers would do. Game developers would create a rock spawn XML file, and that would have all of these little numbers basically defined as variables, and that way they could tweak the game by going to the XML file, changing what some of those values were, and then playing it again immediately and saying, oh, yeah, that's really fun. Oh, no, that's really terrible. And then rinse and repeat until they get something good that they think is a good game. Next piece we need is we got to move the rocks. So we'll iterate over our magic rock collection. And what we're going to do is really, really simple. We're going to take the position of the rock, and to that position we're going to add the velocity of the rock times the elapsed time. And for those of you who remember Physics 101, if I multiply time by a velocity, I get position. I add that position, that actually steps the rock every single frame towards the planet. Now we need to draw them all. So if we come down to our draw routine here, we can do kind of the same thing, which is iterate over the entire collection and call draw model on the rock model. So we're now finally using that. We again need a matrix. In this case, we don't want the rocks to rotate, but we do need to push them out into where they are in the world. Again, we have a helper function for that called create translation. And to that, you simply add the rock's position. So if we fire this up, and I've done everything correctly, we'll compile the new rock model. And yes, what did I forget this time? Yep, I do this every time I have attempted to do this. I never create that rock collection. Maybe I should just put that into some template and say, do that every time. Oh, come on. Okay, so there's the planet. Here comes a rock over there in the distance towards the planet now. And you can see another one spawned up behind him. And they're headed right for us. So you can see the planet is still happily rotating. The rocks come flying in at some speed, and then they magically go right through the planet. So still not done. Fortunately, collision detection is a known difficult problem in the game development space. And since a lot of us that worked on this remembered that when we were working on the framework, we figured out, well, we're going to have to figure out how to help people do that. So we actually created some collision detection functionality in here. And that collision functionality takes the form of spheres, boxes, rays, triangles. All of those kinds of things can be collided against each other very, very easily. And so what we're going to do here is create a new bounding sphere. We'll put that at the rock's position. And then we need the radius, which I am assured by the demonstration here is 3. You don't have to guess at this. There is actually you could actually ask the model what its bounding sphere is, and it will tell you. I'm just not doing that here because this is faster. So if you remember, the Earth or the planet is at the center. Remember, it's at the very center of that thing. We didn't translate it. We didn't move it. We just rotated it. So that's in the center, and I'm assured that the radius for the planet is 6. Then all we need to check is the rock sphere intersecting the planet sphere, not planet model. If it is, I turned you off. My phone never stays off. It's always trying to be very helpful. Yeah. Okay. So if we intersect the planet sphere, then the next thing that we need to worry about, deleted rock. We're going to take the rock and shoot it. Oops, it's true. Then if the rock is actually dead, let's get rid of it. past that rock. So the reason that we put the is dead as a separate check from just putting the flag there is there may be other things that we want to do, or there may be other things that kill the rocks in our game. So we want to make sure that we handle it based on the rock flag being dead, not based on the local condition necessarily telling us that the rock is dead. So at this point, if everything worked according to plan, we can see rocks coming in again. The cool part about this is you often forget that the rocks can come from above. And so when we actually get to playing this, you'll see how much fun, quote unquote, that makes this. There, oh, good. He popped when he hit the planet like a soap bubble. So we're colliding. Great. Now what? Well, at this point, it would be great if the player had something to do. So we have rocks coming in. But besides spin around and look at the planet, which is cool. So we have rocks coming in. They're going to smack into the planet over and over again and hopefully blow it up at some point. So the next thing we need to do is actually add the player controls and pieces and things like that. And rather than do that, because we are running way short on time, let me go ahead and bring up kind of the final version of this here. And I can show you exactly how you do that. So what we're going to do is we're going to create a player position. This is where the player is. The player is going to be on screen. Okay, he's not going to be in 3-space. He's going to be sitting on top of the screen, looking into 3-space, and shooting an invisible laser beam all the time. And if he can get his little pipper to hit one of those rocks, the rock blows up. So in order to do that, I need to know where he is in 2-space, which is enough to cover the screen. I need to know what he is going to be represented by, which is going to be his player texture. And I also probably need to figure out how good he did, which is going to be the score. We, again, load these exactly the same way we would load anything. We load the player texture. We actually keep the position of the player in here in case the resolution changes on the fly. We can actually recenter the player position for you so he's not off screen. We set the score to 0. And for our update, it's really simple. We actually take the thumbsticks on the controller. We invert Y, because that's the way I roll. We have player position is equal to that movement. Then we have a start and end. And the start and end is basically we can actually project using a very simple command on the viewport from, if you imagine that this is all being projected onto this flat screen, but the view cone actually goes out into the audience here, we can actually project from where that thing is on the screen here to the very back of that thing, to imagine the back wall of the audience. And that's going to give us that ray. That's going to give us the beam, essentially, that laser is using. That's going to give us a direction. We create a ray to do that. Again, we can collide rays along with these volumes as well. So we do that as well. We come down here and we say, if the rock sphere intersects this ray, the rock's just as dead, except now I get 100 points. The rock hits the planet, I get minus 100 points. If I let enough rocks hit the planet that I haven't blown up, the planet explodes, and you get the little boop, boop, game over noise. You would if we had sound. So we've also cleaned this up a little bit in terms of looks. We put a skybox in. We put a whole bunch of particle effects in. You can see there's a bunch of stars in there now. And we've also added little trails to the rocks. And you can see here's 2 of them coming in right now. Oh, I keep doing it the wrong way. There's one. You can see he has a big cometary trail coming in. And oh, that's okay. So I lose. It's funny, and people laugh when I do that, but the fact of the matter is it's very rare, actually. Most game development studios never think of trying the losing path. They always just play and play and play and play and play, and they, yeah, I won, ooh, and then, they ship the game out, and they're like, oh, what happens if we lose? Oh, we didn't test that. It turns out if you lose, you crash. Oh, it's all going so well. So now what we can do is I can actually play, and you can see that I can control this little pipper here. And if I can find the rocks in space, I can actually blow them up by mousing over them or joysticking over them. I don't know what the proper verb is for that. Here comes another one in. And I can just keep blowing these things up. And the cool part is every 2 seconds a new one is spawning there. I got them just before you hit the planet. So it's kind of a 3D missile commandy kind of thing. You never run out of missiles. And as long as you can keep hitting these guys before they come in, you won't lose. We don't display the score on the screen right now. That'd obviously be another thing we can do. It's hard to see here, but we actually have a bloom effect on this as well. Bloom is, to modern game development, what the lens flare was in the 90s to game development. Every game in the world had a lens flare whenever you looked at a bright light. Today, all bright lights have a big bloom around them in games. You can see it in the explosions here and stuff like that. And that, again, was we added that exactly the same way we added the orbit camera. We created a new bloom component. We added it to the components. That's all we had to do. Behind the scenes, it catches the back buffer, builds all the bloom buffers, paints all the buffers together, and magically, everything just works for you. And this allows people to share those kinds of components very effectively. Again, a lot of these components are on our website as well, so you can actually go up and look at all of them. So now the next question is, okay, great. What do I have to do to get that on the Xbox 360? Well, the answer is you come in here, and you can actually create a copy of this for either the Xbox 360 or Zune. If you create one for the Xbox 360, set it as a startup project, set that to Xbox 360, and hit the Build button, you can see that we'll actually deploy it to our Xbox 360 here. And if we actually had the joystick plugged in, quick. Whew. Now we can start playing on the Xbox 360. And you'll notice we got the same game. Game developers, professional game developers, have been using this for this kind of prototyping now for over a year. And they can get a game up just as fast as we did right now and decide whether or not this is going to be any fun. They can add a lot of bells and whistles to it, so when they show it to executive management, they can go, see, it's going to be really cool. And they can go, yeah, well, that does look pretty cool. Wow, explosions, I like that. Those kinds of things. So you can actually bring stuff up and running very, very quickly to give you some kind of idea. So the community really fast. Xbox Live Community Games is the pipeline to submit to that is opening up here in the next couple days. You can sell your game via Xbox Live Marketplace, which means when you finished your game, you can submit it to the creator's website. The community will peer review it. The community will decide if you're doing IP violations, if you have illegal speech. We have little checkboxes for that. Beyond that, it's entirely up to the community to decide whether or not the game goes in. We do not do any kind of portfolio management. If you want to write another Halo and you want to post another Halo up there, by all means do so. I would love to play it. There's 4 steps. You create it, which we just showed. You can submit it to the website. The community peer reviews it and looks for stuff that either doesn't play well to give you feedback on, or peer reviews it and says, actually, you're using a lot of X-Wings in this. That turns out to violate someone's IP, so you can't post it. And then once it goes through peer review and it's done, we can actually play it. And you go up onto Xbox Live, and you can actually download a trial mode version of it and play it, and then you can buy it for, it's up to the developer to decide what the cost is. The developers who post these games up get to keep 70% of what they make on it. So you set the price, 200, 400, or 800 MS points. 70% of that goes straight to the developer. These are the regions that we're launching in for consumers: United States, Canada, England, France, Italy, and Spain. The Creators Club is in all the consumer regions, plus Ireland, Norway, Sweden, and the Netherlands. And that means you can get the Creators Club and submit your games from those regions as well. This launches with the new Xbox experience, which you saw here briefly, which is coming on November 19th. So you'll be able to do all that. So again, please fill out your evaluation sessions. This is apparently being put onto a camera, so you'll be able to watch this on MSDN Channel 9. And any questions? Yes, sir. Thank you.
If I have a web app that is running in the cloud, has service in the cloud, storage on the cloud, is there any way to, when I make an Xbox 360 game, it uses that information in those services to create an experience?
Sure. So the question is, can I make an Xbox 360 game using XNA Game Studio that can actually get to the cloud and look at those cloud services? The answer today is no, you can't, because the Xbox 360 is limited to looking only at the live network. It is possible, although if you have to be a professional game developer to do it today, to build your cloud services on something called XLSP, which is the Xbox Live Server Protocol. And XLSP will let you actually connect to, basically it fools the Xbox into believing it's an Xbox too, and then you can serve whatever you want from that. It convinces the Xbox 360 that it's another Xbox. So it looks like another Xbox 360 to it, which lets it bypass the security. Yes. Yes, that particular piece of the cloud is, yes.
Okay, so you can, as a professional developer, kind of bring it to your data.
Exactly.
And is there any qualifications you have to go through?
Right now, you need the publisher's licensing agreement with Microsoft, which means you've got a game that's been approved that would get you a dev kit and those kinds of things in order to be able to do that.
So they would check and see, make sure whatever data you're giving is okay and not.
Actually, they wouldn't care about that so much as making sure that you've got a licensing agreement that says that you're not going to try to reverse engineer any of live, you're not going to do denial of service attacks, those kinds of things with it. So, Any other questions? The versions of .NET, we support from 2.0 up. So this actually has 3.5 SP1 works fine. You can use link expressions. We have all the C# 3.0 features on all 3 platforms as well. We didn't mention that in there, but they are all there. So.
Are .NET updates pushed during the dashboard update?
Right now, no. The updates come via us deciding that we're going to take a new compact framework, essentially. And when we take a new compact framework, we can title update the Xbox, to that new one.
So that was like the last update that happened a couple weeks ago?
Exactly.
If we wanted to tinker with this, do we have to pay that $100 subscription fee, or can we just do it on a local dev machine?
So the question is, what is the cost of this if you're just on your local dev machine? The answer is free.
Oh, so you could just download it and
Yep.
start playing?
For Xbox 360, it costs $100 a year. For Zune and Windows, absolutely free. You can get Express and everything, and you're just done. Yes, sir.
Is there any network connectivity available if you're gaming from Zoom?
Yes, there is. So the question is there network connectivity on the Zune? The answer is yes. We go out through the Zune wireless port. You can only connect to other Zunes right now. We're working on advancing that technology as well. But basically, Zunes will build up their own ad hoc wireless network as they join in. And so you can have, I believe, up to 8 Zunes connecting and playing a multiplayer game that way. Yes?
We saw a crash earlier on a community game.
Uh-huh.
As a developer, would we get that crash dump or stack trace?
Yes. So the question is, do you get access to that crash dump or stack trace? The answer is yes, you can. I'm not sure of the mechanism right now. I know that we track it, and I know that we capture all the data. What I don't know is how that gets back to the developer today.
Second question. I've been a professional game developer for the better part of a decade.
Sure.
And the content pipeline is actually one that I would put on par with some of the best, including id's content pipeline, which I actually consider to be the best.
Cool.
With one exception.
Sure.
And that is, right now, if we make an asset that takes a long time to process, like I know that when I was working on 10 episodes of Emergence, we had some levels that would take 6 hours to compile.
Sure.
Right now with the content pipeline, every developer would have to pay that 6-hour cost every time the asset got updated.
Correct.
Is there any hope of getting it so that we can get these assets to offline process?
So offline processing is an interesting question right now. Right now, the answer is no, because MS Build doesn't have a lot of concurrency built into it. It's all kind of single-threaded. The good news is that there are multiple content projects now in Xbox or in Game Studio 3.0. So with Game Studio 3.0, that 6-hour level could live in another content project. And when you updated your network that night and built these 6-hour things in your background build process, you could actually download the content project plus all the binaries and object files for that level. And that person would not need to rebuild that morning. It would already shown up as already built. It's in a separate content project. And then unless a dependency changed in that level, you'd be fine.
Thank you.
Is there any thought of porting some of this to Silverlight?
Yes. There's a lot of thought around that. We don't know any kind of specifics yet. But I think, yeah, pretty clearly getting this in Silverlight to be in the same universe would be awesome.
So are we thinking like over a year or two?
It's hard to say, honestly. It's gonna revolve around manpower and priorities and stuff like that. The good news is that we're just shipped 3.0 right now. So we're going to be coming back. One of the things I get to do when I go back to Redmond is actually sit down and start to plan out what the next releases are going to look like. And that's certainly a priority, a pretty high one.
Cool.
So, thank you very much.